to Schneider Electric's Cooling Innovation Day. While with many things these days, I wish that I could have you here together with us in person, I'm excited that we're here together virtually to share what's happening in the market, our new offers, and innovation and sustainability efforts driving our future. As many of you know, digitization and sustainability are core to our strategy as Schneider Electric. Our purpose is to empower all to make the most of our energy and resources by being your digital partner for sustainability and efficiency. And so too, this is core to our strategy in the cooling business. Whether it's leveraging the latest low GWP refrigerants in our chillers and cracks, endeavoring to limit the waste of water in our systems, or to ensure our solutions are highly energy efficient, we are working with our customers and partners to ensure that the digitization trend is a sustainable trend. Over the past 2 years, the word unprecedented has been used a lot, whether it's to describe the COVID pandemic that has impacted our lives, both personal and professional, or to describe the rate of growth we've seen in the data center market. What's clear is that the pandemic has accelerated digitization trends globally. In the way that we work, the way that we go to school, the way that we connect with friends and family, how we consume content, or through the proliferation of connected devices in factories, buildings, and homes to make them smarter, more efficient, and safer. Digitization is here to stay. While the most obvious growth is in the cloud and with the largest of data center operators, as the pandemic has eased, we've seen a rebound in edge deployments as well. And throughout this event, you'll have an opportunity to explore content related to sustainability, innovation, and offers catering to these environments. I encourage you to explore our thought leadership on topics such as sustainability, liquid cooling, and natural refrigerants in the auditorium, to visit our solutions in the exhibition hall, including the new range of XRA chillers and our 300mm DX in-row with economizer that helps you to meet local sustainability regulations like Title 24 in California, or to visit the lounge and interact and engage with our experts. And with that, I welcome you again to Schneider Electric's Cooling Innovation Day and would like to introduce Pankaj Sharma, our Executive Vice President for Secure Power and the leader of the data center business for Schneider Electric. Happy exploring.
Hello everyone. It is my pleasure to be here with you today to talk about the innovation and the overall opportunity in the data center cooling industry. I know you are going to spend the next couple of days sessions talking about innovation in this space. So I just wanted to bring about 3 pieces which I think are extremely important for us to consider. Number one being data center cooling is an integral part of Schneider Electric's overall cooling solution. Not only it's an integral part, like I said, it's also almost a door opener for a lot of new data center opportunities. And to that effect, which is the number 2 piece, I have in the last about 60 days met a lot of data center customers, both hyperscalers and cloud colos in US, in Europe, and other parts of the world. And I can tell you the demand for cooling inside the data center space is just increasing substantially. So even more important for us to stay focused on what we need to do, which is then going to the third point on innovation. It's not just about having the existing solutions which we are going to put in the data center space. It's more than that. We need to continue to innovate. You know, there was one data point we were looking at earlier that if you had a 1 megawatt data center, the amount of water it consumes in a day, and this was a US example, was almost 300,000 gallons of water. So obviously, given our sustainability goal, our mission and our purpose as a company to do well, to make a greener planet for the future, I wish you luck in your innovation journey over the next couple of days to make sure we find ways to come up with solutions which are completely sustainable and helping do well for the planet. So good luck with your sessions, and it is again my pleasure to be with you here today. Thank you very much.
Thanks Pankaj and Andrew for your valuable inputs on thought leadership of Schneider Secure Power Business Unit. Hello, I am Pankaj Pathak, Global Director, Product Management and Marketing for Schneider Cooling line of business. I welcome you all to this Digital Cooling Innovation Day. Today, we all live in digital world, and even right now, we are connected digitally with each other. That means digitization has never been so crucial in past. This is creating new demands around cloud computing, big data, and cyber security. These changes are being driven by more users on social media platform and hence more data and a lot more reliance on IT infrastructure. Cooling is a crucial backbone for running any IT infrastructure and data center to ensure uninterrupted connectivity and storage. Reliability, efficiency, and sustainability are the key pillars for smooth functioning of any server room. Schneider Electric, which has been ranked global number 1 as world's most sustainable company, offers unified range of cooling solutions to support these demands. Schneider cooling solutions are perfectly designed to meet all these crucial expectations from our global customers. Unified cooling product ranges are available in full spectrum of applications like edge and micro data center, small to medium server room, and for large colos to hyperscale data centers. The in-row, rack mount, and small cooling units are perfectly suitable for edge and micro DC applications. Access floor, chillers, DX and chill water cracks caters to the all needs of SMDC segment. The hyper front flow chill water units, Mega CRA, and a vast range of air cool and water cool chillers are perfectly designed for the customer from cloud and service provider as well as for large colo. Uniflare chillers and precision air conditioners are offered with latest options like variable capacity control, the newest refrigerant, and many more to comply with the norms of efficiency and sustainability. The product range are available with options of new refrigerants like R32, R454B, R1234ZE, and R1234YF, which has global potential, the GWP, as low as just 7 and 4. Our new range of economizer in-row meets all the latest efficiency criteria of Title 24 from California in United States and comes with a global green level certification. The TL 1.2 level network management card offers the adherence to the latest cyber security norms. So we are inviting you to explore all these latest Uniflare products and solutions in the different sections of this event. You can discover individual product booths which are dedicated for different product lines inside the Innovation Hub. For each product, the brochures, the product presentation, 3D sketch fab, BIM models, and many more documents are available. Just add them to your swag bag and you will receive them via email. Take a seat inside auditorium where the data center specialist will talk about innovation, strategy, and future of data center cooling. And don't miss the application center area, which will provide you a varied regional flavor. It will be our pleasure to have your questions and queries, which you can post in the Interact with the Global Cooling Expert section. The product experts will reach back to you directly. And don't forget to check the leaderboard tab, which will have a hidden surprises for you. So, looking forward for your interactive engagement in today's event. Thanks for joining and happy cooling.
Good day, ladies and gentlemen. I'm happy to welcome you all to this summit, which is dedicated to the importance of cooling systems for data centers. As we all know, for different reasons, over the past few years, the number of data centers has dramatically increased, and the demand for them continues to grow. Now, maximizing energy efficiency and sustainability of data centers and cooling systems in particular have become extremely important. We as a company investing greatly in this aspect of our business, and we believe you will be encouraged by the presentation of our technological achievements. You are our clients, and we are very grateful that you trust us and rely on our innovations that can be seen with the increasing number of major worldwide projects with which we have been awarded. The favorable response from market professionals is our motivation not only to be better, but to be the best. I hope the discussions and ideas that are raised at our forum prove to be beneficial to all of us.
Hello everyone, my name is Rob Kernan, Senior Vice President of Secure Power Europe. I'm speaking to you from Consolve, Italy, our worldwide headquarters for our cooling business. Our focus here in Consolve, as well throughout the entire globe on innovation over the last 10 years, has been a key driving of helping our clients and partners meet the needs of an evolving data center landscape. Throughout this event, you will see our ongoing focus on innovation today. Here in Europe and throughout the world, a key focus of this innovation must be on sustainability. The focus on cooling inside of our data center to be more sustainable, as well as the continued high levels of efficiency and effectiveness, is more important than ever. I hope you have a great event and look forward to our continued collaboration on these topics and all the topics around your data center needs. Thank you.
Welcome to Cooling Innovation Day. Today I'm going to share a bit about Schneider's vision on the liquid cooling frontier. In today's world, everything is digital and supported by data centers. Artificial intelligence, big data, and high-performance compute dominate the landscape, with the latest CPUs and GPUs supporting these workloads becoming denser than ever. Intel and AMD are already shipping processors with a thermal design power of 400 watts. NVIDIA's latest offering of AX100 GPUs are at 400 watts, with rumors of next-gen series north of 500 watts. Rack densities are increasing, with current projects designing to over 100 kilowatts per rack. We have reached peak air, and the ability of existing technologies to solve these problems is at the point of diminishing returns. Something had to change, and we've got the technology for this exciting shift: liquid cooling. Not only does liquid cooling address the density problem, but it also supports Schneider's vision on sustainability. Liquid cooling reduces energy consumption, water usage, and allows for white space footprint consolidation. Compute that once took the space of a football field can now be achieved in the space of a two-car garage. It can also work in the harshest IT environments and can reduce or eliminate noise. There are 5 main architectures for liquid cooling, separated by direct-to-chip and immersive technology branches. Direct-to-chip, in which liquid flows to a cold plate that is mounted to the processor, and sometimes memory, removes 60 to 90% of server heat via the liquid. Liquid does not come into contact with the IT components. Immersive is broken into chassis and tub immersion methods and removes 95% of the server heat via a dielectric liquid that is in direct contact with the IT components. Both branches offer single and two-phase methods as well. A typical liquid-cooled data center infrastructure has a dry cooler or chiller providing warm water on the primary loop, also known as the FWS, Facility Water System, to a cooling distribution unit, which will deliver water at the right temperature, pressure, and chemistry to the IT equipment via the secondary loop, also known as the TCS, the Technology Cooling System. It is important to note that data centers will not be 100% warm water cooled in the future. Most data centers will have a mix of air and liquid cooling for the foreseeable future. Not all components, UPSs for example, can be warm water cooled. Some air cooling will be needed to scavenge the heat left over. While Schneider continues to monitor and explore all technology architectures, we have made some key moves on 3 of the paths. On the immersive side, Schneider Electric has partnered with chassis immersive pioneers Isotope. The fluid is encapsulated in a clamshell chassis and is mounted just like an air-cooled server. Some light engineering work is needed to design the conversion. We see this technology as an excellent fit for harsh edge environments, high-performance compute where fanless and rack-based is preferred, and those that have an aversion to the sometimes messy nature of tub immersion. While some manufacturers like Lenovo have already qualified servers for this technology, we have options on warranty for those servers not yet qualified through an integration partner called Avnet. On the direct-to-chip side, Schneider Electric is developing a positive pressure CDU capable of 600 kilowatts, and last month announced our most recent partnership with Chilldyne, a negative pressure CDU system capable of 300 kilowatts. Negative pressure, otherwise known as LPS, leak prevention system, is extremely interesting to those concerned about uptime and the risk of water in their data center. If a piping or manifold were to become damaged, instead of leaking water, it sucks air into the system and keeps operating until the damage is repaired. Connectors in the server and at the rack are significantly simplified and cost-effective. The cold plates are easily retrofitted into existing servers and can be finned to offer continued operation. Either of these CDUs could also be used in conjunction with the Isotope solution as well. We have liquid cooling reference designs for existing and new data centers for those wanting to dip their toes into liquid cooling as a proof of concept, and also those customers who wish to do larger installations. At the same time, we are also developing bespoke dry coolers, trim chillers, and high evaporating temperature chillers for use in liquid cooling applications. I hope you have found this brief introduction to liquid cooling interesting. Liquid cooling is the key way in which Schneider will address the changing landscape through innovation and sustainability. Thanks for joining.
Good morning, good afternoon, and good evening, and welcome to the Cooling Innovation Day. Thank you for joining this session where we will discover together what we will see for the future of cooling of data centers. Certainly, the data centers are growing and they are evolving, and there are plenty of different areas where the data center, in particular cooling for data center, is evolving. But three of those are, in our opinion, the top three areas where we as a manufacturer and all of you should cooperate in order to get a much better data center design than in the past. We can look at what is happening and what will happen on size and type of units, will be the impact on our planet about data center, and last but not least, where and what will happen, the evolution to liquid cooling. But certainly, the top part is what is happening in terms of unit feature and unit size. We are reflecting this, we are capturing this, looking at our latest years, but looking at the future, it's clear that capacity and complexity for cooling machine are growing and growing significantly. This is because, of course, larger units and a more packaged unit, a more prefab unit allow to have an easier way to deploy the data hall, to manage the large and extra large hyperscale affected the data center, and to comply with the most recent Australian regulation. So having units which are much more large than in the past, much more equipped than in the past, is a key trend. It is something that is coming from the past, but certainly will be part of the future. And the more we can cooperate in getting larger units, the more the data center will be ready for the future. However, size is only one portion of the unit evolution. Certainly, having a different typology of cooling, air economizer, cooling towers with water-cooled chillers, pre-packaged chillers, direct expansion units, is something that is fine when you have regional-based data center or small and mid-sized data center. While when the collocators and when the data center are evolving to be global, to be general, and to be extra large, a general standardization of the cooling methodology is necessary. And the only one among the different typology of cooling that comply with this requirement is air-cooled, with or without free cooling, chillers connected to CRA and chilled water installation. This does not mean that the unit will be the same regardless the region. However, this means that with a chilled water-based system and an air-cooled chiller, the data center can easily manage the different regulation in terms of efficiency, in terms of refrigerant usage, typology of refrigerant, minimum efficiency requirement, and last but not least, the evolution to liquid cooling that we will see later. So one recommendation and key trend is to focus on air-cooled chillers with or without free cooling design and general chilled water systems. This is on the unit. But certainly we cannot forget the impact that the cooling machine has on data center and the data center has on our planet. There are no way the data center are impacting and will impact a lot of any of the feature of our planet. Our planet deserves to have a data center more sustainable, with less energy consumption, less water consumption, less material consumptions. And that's something that is evolving and will be the future. So there are necessary to have technologies, choices, and selections based on having a sustainable data center. There are different, again, methodologies, but certainly the top four are based on energy minimization, greenhouse emissions reduction, water dependency reduction and water usage reduction, and last but not least, certification that cover the entire data centers. All of those probably need a specific workshop, but there are some pills which are very important and can be driver in our choices in our cooperation. Looking at how much efficient can be the unit with a very high water temperature, with a water temperature designed for the future evolution to liquid, new refrigerants, and how we can reduce the GWP of the unit without impacting too much or on the power consumption. The dependency on water and the usage of water is another key topic that we need together to remove from the equation of data center. And last but not least, we need to have a global end-to-end view of all the data centers cooling, which means to certify the data center, to certify the product, and to have a life cycle assessment for the data hall and specifically on the cooling, which is the large parts of impact of the data center. Last but not least, liquid. All of us knows that liquid cooling will come. Sooner or later, the evolution of the server will be on liquid to handle capacities up to 100 kilowatt per racks. That's a fact. The big point is that although we migrate to liquid, regardless the different typology of liquid cooling that the data hall will use, heat rejection will anyway necessary, and anyway cooling will be necessary to cool the liquid. And the percentage of air versus liquid will change according to the different typology of liquid cooling, but certainly again, heat rejection will be necessary. Second big point is that regardless again the typology of liquid cooling, the migration to liquid won't happen in one step, won't happen immediately except for few cases. The migration will be slow and step by step in the next probably 10 years. So the big challenge is how we can design today to be ready for an evolution to liquid of the data center without redesigning from scratch everything every couple of years. There are ways to do this, and we are again more than happy to cooperate together in providing the device to work on a few racks, 1-2 racks, or to have 1-2 rooms, and we are deploying the product around this, and when the data hall will be mainly evolved through liquid. The big point again is which kind of technology we will use together, which kind of cooperation we may have, but the good thing is that products are on the way, and the big point is that they are not completely different from what we are doing now, but will require a cooperation between manufacturers, consultants, specifier, and all the ecosystem that data center has in the market. Those are the top 3 areas where we see the data center will evolve, and we are sure that the more we can cooperate together, the more we can work together, the more these 3 topics will be part of our future to create the next generation of great data center. Thank you. Thank you for joining me, and I really hope that you enjoyed this presentation. Again, let's stay tuned to the others, and thank you again. Good morning, good afternoon to everybody, and thank you for joining this Cooling Innovation Day. Data centers are certainly one of the key topics when we talk about sustainability, because the energy impact and the environmental impact the data center has. If we look at the overall United Nations target for sustainability, the majority of those are impacted by data centers because they are definitely the most impacting in our ambient. So sustainability is not just greenwashing, it's a real way to preserve our planet, and the design rules and guidelines on that are mandatory to have this target. We identify many of those, but the top 4 are certainly water, minimization of usage, minimization of energy, water dependency, no greenhouses, and a final holistic view on the all over the topic. The 4 drivers requires our environmental and our cooperation. Certainly looking at how to design a data center, which are the best temperature to design the data center, this is one of the key drivers to design for sustainability. And there is a big battle between chillers and CRA, what is the best one in terms of high water or high ambient condition operation. And certainly when we increase the chilled water temperature, the chiller are getting more efficient and the CRA are getting less efficient. But who wins this race? Combining it together, it's clear that what the chiller get is much more than the CRA lose. So the target is to design the very high chilled water temperature, pretty wide, the delta T, without thinking too much about the CRA or the fan wall and how much this is the impact on their efficiency, because the chiller are the driver in terms of efficiency. So the first guideline is try to design at the highest water temperature possible according to the ASHRAE regulation. The point number 2 is the refrigerant topics. We are evolving in this topic. We are evolving in the market, and the regulation from the market are evolving with us. Since many years, there is a big trend to reduce the refrigerant impact in the atmosphere, and the most recent Kigali Agreement is forcing all the nations to reduce the global warming for the current refrigerant. This is unfortunately generating a lot of complexity. So again, it's important to define together between us as manufacturer and the EU as designer, which is the best refrigerant at all. And unfortunately, it is not only one choice. The choice depends on the application, depends on the country, and depends on the operating condition. But the general guideline is that the more we move on chilled water application with air-cooled chiller, the more we can use the low GWP refrigerant without considering the flammability and without problem on that. On the other hand, we should not consider that natural refrigerant are the only choice to be very low environmental impact, because currently the low GWP is also from synthetic refrigerant, and the energy impact and the end-to-end impact for natural refrigerant is not yet for data center application mature enough to have a proper high level of efficiency and low level of energy and environmental impact. So definitely we need to move on looking at the synthetic refrigerants, but we need also to look at water. Plenty of different applications requires water, and adiabatic was one of the key trends in the last few years. Nowadays, water is the new oil and the new power, and we must take care about efficiency, about high ambient operation and extended capacity without water. We can use water to boost that, but definitely we should not depend on water, and we should design without considering water in the equation. Last but not least, we need to have a full comprehensive view of the market and on the application with the end-to-end approach. So not only looking at what is the chiller or the CRA producing in terms of energy efficiency or resource usage, but the entire life cycle. So LCA activities are mandatory to certify and check what are the best data center at all. And certification as the Eco Passport and the BREEAM are a viable way to certify the data center even on a specific environmental impact. So that's all. Those are the main points. We need to forget all the design only on the cost and the total cost of ownership. We need to design in minimizing the impact of the energy of the data center. We need to minimize the usage of all the refrigerant high GWP. We need to not be dependent on water, and we need to have a holistic view, including certification, for the best data center and the most sustainable data center of the future. Thank you.
Welcome to Cooling Innovation Day. Today I'm going to share a bit about the latest edition of ASHRAE thermal guidelines and what they mean for you. The ASHRAE Thermal Guidelines for Data Processing Environments is a volume of research and recommendations that is developed and published by the ASHRAE Technical Committee 9.9. TC 9.9 is the largest and most active technical committee with over 350 members, with members including manufacturers, consultants, researchers, universities, utilities, regulators, contractors, and government. The purpose of TC 9.9 is to be recognized by all areas of the datacom industry as the unbiased engineering leader in HVAC and an effective provider of technical datacom information for mission-critical facilities, data centers, technology spaces, and electronic equipment. The primary source of information on the latest IT trends used in the development for the thermal guidelines comes from the TC 9.9 IT Subcommittee, which is composed of R&D engineers from all of the major IT equipment manufacturers and enjoys robust peer review from members representing owners, operators, and consultants. The three major areas that were updated include relative humidity limits for air-cooled equipment, a new air-cooled class for high-density compute equipment, and a greatly expanded liquid cooling chapter. In 2019, TC 9.9 completed a research project centered around the effects of gas phase contaminants on silver and copper corrosion under varied elevated relative humidity levels. The outcome of the project confirmed that adjustments needed to be made to the upper end of the relative humidity range based on concentration levels of pollutants in the IT spaces. Applying these recommendations can be achieved at your own site by using commonly available silver and copper coupons to track and verify corrosion rates. The second major update was the creation of the new H1 class for the high-density air-cooled deployments with a recommended upper end of 22C. Increased power density of the IT equipment necessitates a cooler thermal envelope for reliable operation. Does your space fit the definition of H1? Well, maybe. Unfortunately, there's no standard ITE design, so you must consult with the manufacturer of your ITE equipment to determine if you can go with H1 or the standard A1 class. You can also find extensive application notes and other information within the new edition of the guidelines. As mentioned before, the new edition contains the most updates to the liquid cooling chapter. Since the last revision was published, there has been continued emergence of new liquid cooling technologies on both the direct-to-chip and immersive architectures, and also the IT equipment that supports those technologies. These new advancements require updated guidance. The liquid cooling class designations have been redesignated based on their upper temperature limit. Previously, the classes were designated sequentially W1, W2, W3, W4, and W5. Each of those classes had a lower temperature limit of 2C, while the upper limits were 17C, 27, 32, 45, and 45C respectively. Spurred by regulatory demand for heat recovery and reuse from data centers, and an interest in using liquid cooling solutions as a means to do so, several manufacturers designed solutions around 40C entering facility water. As such, a new class for 40C water was added. At the same time, it was decided to make these classes easier to remember what temperature goes with what class, and also be more agile to make future adjustments based on industry demand. To that end, the new classes are now called W17, W27, W32, the new class W40, W45, and W plus for anything over 45C. Another notable clarification made in this edition is centered on the definition of IT equipment compliance within a respective W class. To alleviate confusion among manufacturers and designers, the new definition for compliance is, quote, full, unthrottled operation of the ITE at all temperatures within the respective W class, end quote. Lastly, there is a discussion around the facility water system design pressures for liquid cooling systems. There are liquid cooling solutions on the market today which have maximum system working pressures below that of traditional FWS systems, which could lead to a load drop as the IT equipment shuts down to protect themselves. The use of a cooling distribution unit to deliver water at the right temperature, pressure, and chemistry to the IT equipment is one way to alleviate these concerns. I hope you have found this brief update on the latest edition of the ASHRAE Thermal Guidelines interesting, and I would encourage you to pick up a copy for all the updates, clarifications, and additions. Thank you for joining.
Welcome to Cooling Innovation Day. Myself Bashir. I am working as a technical expert for Cooling Innovation and Strategy team. Wondering how to improve the efficiency of an existing data center facility? Then this session is for you. In an effort to create a clean energy economy, there is a huge demand in the market to increase energy efficiency and reduce carbon emissions in data centers. With the high cost of power, energy efficiency has rapidly become a critical consideration when evaluating data centers. It is perhaps second only to performance when deciding upon a data center. High energy consumption is a recurring cost that can add dramatically to operating expenses over time. Furthermore, devices that consume more power require more cooling, which not only further increase energy costs but impacts the physical design of the data center. For the next few minutes, let's discuss more about the breakdown of sources of data center energy consumption, what is the challenge of energy efficiency improvement, how a data center efficiency assessment can help, also factors impacting efficiency measurement, and at last, best practices to realize the energy efficiency gains. Physical infrastructure accounts for more than half of the total energy consumption of a typical data center. For every watt your computer equipment uses, data center requires more than 2 watts of power. Roughly up to 40% of energy consumption of a DC is due to cooling, depending on the technology adopted. Since we know where the energy goes in the data center, let's discuss on challenges we have in raising the data center efficiency. The goal of achieving greater efficiency is a significant challenge for many existing data centers because physical infrastructure is not capable of supporting the high densities required for optimum utilization of footprint. They are also faced with existing limits to power and cooling capacities. Physical infrastructure not supporting the utilization of new cooling technologies is a big problem. And also, power wasted both in non-critical infrastructure and IT equipments is a big problem. The good news is that using innovative best practices, utilization of measurement tools, and deployment of modern technology solutions can reduce the data center electricity bill by 20-50%. In addition to making an efficiency measurement, a data center assessment report typically provides analysis of the built configuration and recommendations regarding efficiency improvement. A proper assessment can produce the following outputs like identification of problem areas, recommendations for quick, inexpensive fixes, recommendations for organizing a long-term energy efficiency strategy. Using online tools from Schneider Electric, we can roughly calculate the data center efficiency and carbon footprints. Variable conditions in a data center can cause a change in the efficiency over time. Several factors have a major impact on the data center's efficiency like IT load, outdoor conditions, user configurations and settings. Data centers running at low loads are less efficient than data centers running at high loads. The efficiency of a typical data center declines as outdoor temperature increases. Users take a variety of actions that affect the PUE like change of temperature or humidity set points, moving or adding ventilated floors, tiles, or failing to clean air filters. All these factors affect the efficiency. Shown are some of the strategies which can be deployed for increasing efficiency of existing data center facilities, like tuning redundant systems to leverage savings on partial load operation. Capacity management tools help to minimize stranded capacity within the data center. Existing building structures often limit the electrical efficiencies that can be achieved through power and cooling distribution. Modular containerized solutions help you to overcome this problem. Free cooling systems save energy by utilizing outdoor air during colder months of the year. Hot air containment allows higher work environment temperatures, and together with increased chill water temperature operation can result in further economizer hours and significant savings. Also, DC operation in A1 envelope can further increase economizer hours. Using adiabatic cooling in certain ambient can further help to increase efficiency. Also, airflow management tools and using CFD analysis and DCM tools all can help to improve efficiency further. Key takeaways from our discussion: energy efficiency initiatives in data centers can begin with assessments that can get the low-hanging fruit. Techniques such as blanking panels, hot air, cold air orientation of racks can begin the process of improved energy efficiency. Accurate measurements data is the essence of improvement, so energy consumed is the baseline for improvements. Data center energy efficiency models can be used at a reasonable cost to measure consumption to a surprisingly accurate degree. Once consumption is measured, management techniques and new technologies can then be deployed with significantly reduced costs throughout the electrical, mechanical and IT room of the data center. I hope you found this brief session interesting. Efficiency improvement is the key way in which Schneider Electric will address the changing landscape through innovation and sustainability. Thanks for joining.
Welcome to our Cooling Innovation Day. I'm here to introduce an important portion of a Uniflare chiller portfolio that is covering from 6 kW up to 2.3 MW. Our chillers are designed for mission-critical application to ensure robustness and reliability to our customers. The focus of this presentation is the mid-large portion of the range in air-cooled or free cooling version that are called TRA or TSA according to the compressor technology. The key 4 drivers that we need to keep in our mind in our chillers are highlighted in this slide and are the wide portfolio configurability in order to be flexible and adaptable at the same time, the high efficiency levers of our units in order to help our customers to minimize their partial PUE in a data center application, optimizing the total cost of ownership. The global solution in order to have units to be suitable for critical environments all over the world, and sustainability using new refrigerants in our units. A wide portfolio is the key to be flexible and adaptable for multiple applications. Our TRA range is composed by 10 models up to 580 kW, and this is equipped with 2 or 4 fixed-speed scroll compressors operating on 1 or 2 independent refrigerant circuits. The parallel range is called TSA, and the key differentiator is the inverter-driven scroll compressors. These units are able to provide up to 470 kW, and they have 5 models with all components selected and optimized to have the best possible efficient in a compact footprint. And the wide unit configurability is the real advantage when we need to have a unit with several options and a small footprint. All our options are integrated in the unit dimension without impacting the footprint of it. Starting from the first one, the user side pumps, we can select 1 or 2 pumps integrated in the unit in fixed speed or variable speed configuration with a water tank inside. We can select a double power supply with automatic transfer switch that commutates from the main line to the second line in case of a power outage. If we have constraints in noise limits, we can select several options to reduce the noise emission of the unit. And if a customer does not want glycol inside the data center, we can have a complete separation of the hydraulic circuit from the main circuit with pure water only and the free cooling circuit with glycol inside. This is the glycol-free option. Last but not least, we need to protect our chiller from critical environments with electrolytic treatment on the air side coils to prevent corrosion, with metallic filters to protect the unit from sand and pollution, and with lateral metal grills. On the efficiency perspective, we need to maximize the efficiency all over the year. The first weapon that we have is the inverter scroll compressor that allows a unit to save up to 15% of energy over the year. On top of that, we can combine a free cooling unit with high water set point and wide delta T in order to save up to 45% of the energy over the year and to minimizing the total cost of ownership. And if you want to make a further step, we can select our adiabatic solution that leverage on the water evaporation effect to provide more efficiency both in mechanical mode and in free cooling mode, allowing an additional 10% on the energy saving. And highlighting few numbers, I would remark the last one that is called the SEPR that measures the seasonal efficiency of a chiller in an IT or process application. With these ranges, we can achieve up to 7.1 that exceed the co-design directed limits by the 40%. The mission of our chillers is to be as much global as possible in order to be suitable for different climatic conditions. We need to consider 3 important numbers. 50 degrees C is the maximum ambient temperature at which our chillers can operate in full load and not in protective mode. Minus 40 degrees C is the minimum ambient temperature at which our chillers can operate in total free cooling mode. And 20 degrees C is the usual water set point for the next generation of data center that our chillers are able to achieve. On the sustainability equation, we need to consider efficiency on one side, but new and greener refrigerants on the other side. Our mid-large chiller portfolio is ready for the future, and our solution is the R454B, as alternative to the traditional L410A. The new refrigerant has a GWP, the global warming potential, of 466, much lower than the previous refrigerant, with a less atmospheric life and better performances. Uniflare TRA and TSA chiller is the solution to support our customer, providing a flexible, adaptable, efficient and sustainable chiller. Thank you and enjoy our Cooling Innovation Day.
Welcome to Cooling Innovation Day. Do you know that Uniflare has a complete range of cooling units for edge and telecom applications? When we discuss edge or telco applications, it's small rooms that require small capacity cooling units. That means cooling units must be having plug and play type. It must be compact and compliant with the local regulations. Being remote locations, it must be highly reliable, efficient and mechanical, as well as free cooling operation and easy to maintain. It has 3 variants: wall mount outdoor applications, room cooling for indoor applications and ceiling suspended for split applications. So let's explore them one by one. Monoblock units are meant for outdoor installations. These are external wall mount units with a cooling capacity ranging from 4 to 17 kW. Units are factory charged with refrigeration gas R407C with efficient and reliable scroll compressors, condenser fan speed regulations and advanced microprocessor control that manages multiple modes of cooling operations. Other than this, there are options of electrical heaters, high efficiency filters, double power supply, user terminals and remote monitoring through Modbus or TCP/IP. Wall mount units are meant for telecom applications for the reliability, efficiency and free cooling. Secondly, all the components are accessible from outside. That means technicians can perform the maintenance without entering the shelter. The unit has 3 modes of operations. Mechanical cooling. In this mode, as the ambient temperature is higher than the room set point temperature, the compressor and condenser fans are switched on to deliver the cold air. You can see the hot air path in red color and the cold air path in the blue color. In free cooling mode, during winter or night operation, when ambient temperature falls below threshold value, free cooling gets enabled. You can see the damper position change and outside air is pushed inside the room and hot air expelled outside. In this mode, compressor and condenser fans are switched off. It's most economical mode as customer gets maximum saving during this mode of operation. Last, emergency free cooling mode. As word emergency describes, there might be failure in compressor or condenser or mains for failure. In this situation, controller try to maintain the room temperature equal to ambient temperature by positioning the motorized damper that enables emergency free cooling mode. Quick look on the dimensions. Second product, monoblock units meant for indoor installation. These are indoor monoblock units with a cooling capacity range from 6 kW to up to 15 kW. Units are factory charged with refrigeration gas R407C with efficient and reliable scroll compressors, condenser fan speed regulations and advanced microprocessor controller that manages multiple modes of cooling operations. Other than this, there are options of electrical heaters, high efficiency filters, double power supply, user terminals and remote monitoring through Modbus or TCP/IP. In monoblock units, all components are accessible from inside the room. Thus, these units are installed where access is not possible from outdoor side. It has 3 cooling modes: mechanical, free cooling and mixed mode. A glance on dimensions. Actual picture references for outdoor wall mount and indoor install units. Our last product is ceiling suspended split units. As word described, it has 2 sections, indoor and outdoor, interconnected with copper pipes, power and communication cables. Being ceiling suspended, it doesn't occupy precious white space within room. Cooling capacity range from 6 to 15 kilowatts. Units are field charged with refrigeration gas R407C with efficient and reliable scroll compressors, condenser fan speed regulations, advanced microprocessor control that manages multiple modes of cooling operations. Other than this, there are options of electrical heaters, high efficiency filters, double power supply, user terminals and remote monitoring through Modbus or TCP/IP. It has 3 cooling modes: mechanical, free cooling and mixed mode. Dimensions of split indoor and outdoor units. Picture references for split indoor and outdoor units installed for prefab shelters. Summarizing, Schneider has dedicated range of cooling units for edge and telecom applications. All three variants has its own unique applications. Apart from this, They are most reliable, energy efficient, and built in with smart microprocessor controls. Thanks for joining. If you are looking for a latest generation compact cracks, then Uniflare AM units are the right choice for you. The Uniflare AM units are compact, efficient, and perfect solution for small IT spaces. These units are having fully front accessibility. That means units can be installed close to one another. With the new Schneider control, the connectivity has been improved with a particular attention to the most advanced data protection. Uniflare units offer wide range of air configurations. If there is a race flow, it has downflow variants with a front or top air intake. In case server room are without race flow, then it has upflow variants that offers the hot air intake from front, bottom or back of the unit and delivers a cold air upward direction. Uniflare AM series has 3 variants, starting with minimum cooling capacity of 5 kW to up to maximum 20 kW. If there is a space to install remote condenser, air-cooled direct expansion units are the ideal solution. If there is no outdoor space available and customer has medium temperature water available from cooling towers, then direct expansion water cool can solve your problem. Lastly, if customer has chill water source available, then chill water units is the most economical solution. This unit has option of latest generation energy efficient EC fans having better fan speed regulation or traditional high performance centrifugal fans that offers speed regulation and low noise level. Units with refrigeration circuits offer on-off type scroll compressors with a refrigeration gas R410 with the options of traditional mechanical expansion valve or electronic expansion valve. Chill water units are available with options of 2-way or 3-way chill water valve that has low water pressure drops to reduce the pump energy consumption. Uniflare AM units are equipped with sophisticated controls and management software developed by Schneider thanks to extremely user-friendly touch screen display to manage complex operation with a very simple actions. The touch screen is provided with USB port integrated that allows easy upgrade of the software and data download. These units are built with integrated cards, clock cards for real-time based alarms, LAN cards with a connectivity up to 15 machines, USB connections for data download and firmware upload, RJ45 connector for communications like web server, SNMP or Modbus over IP or BACnet over IP. Additional modules for protocols like LAN, Modbus RTU or BACnet MSTP. Most important is the cyber attack protection is improved in these particular machines. It has ability to interface with 2 separate BMSs, natively integrated with the EcoStruxure IP. Summarizing, Uniflare AM series units are very compact with multiple air configurations, built in with efficient and reliable components, user-friendly control that offers improved connectivity and most advanced data protection. So, don't hesitate to reach out our sales team for your compact data center requirements. Thanks for joining.
Hello, welcome to our Cool Innovation Day. I'm Francesco Mortandello, the Global Offer Manager for Cloud Distribution, Digital Tools and MES. So let me introduce the Schneider Electric commitment to cybersecurity. So we live in a hyper-connected world where everything is connected, from retail up to industrial automation, from our private lives up to our work activities. So everything is connected. Just one number, on 2017, the number of connected devices was around 20 billion. By 2025, this number is expected to be around 80 billion, with a huge increase of the gigabyte traffic. And by 2025, the business spending for AI is expected to be around $232 billion. But what are the drivers creating a cybersecurity protection request? Into your architecture, you have the physical security, so the protection of your perimeter by fire, vandalism, theft. You have the IT security, so the protection of your computer system or your software electronic data. And the OT, operation technology, where software and the hardware are used to carry out processes. Cooling units are part of OT. Cooling units are part of HVAC. And the new threat is coming by HVAC. So this new figure that want to use the air conditioning operation to create the damage to the data center. So it is clear that the cyber criminal have different targets, so different typology of data to be stolen. We have different landscape, different motivation. The simple virus up to the industrial espionage or the attack to the government. And also cyber security ventures as predicted on 2031, a ransomware attack every 2 seconds. So the company has to pay a lot of money in the future to rescue stored data. It's clear that all the departments inside the organization play an important role, and also Schneider and the customer can act as a unique team for a common success. It is mandatory to identify the crown jewels, so to have a right separation of critical and non-critical network, to adopt defense in depth, threat modeling, and adoption of least privilege mechanism, right authorization, right restriction. So the cybersecurity is a collection of training, diligence, policies, and best practice to protect your asset. So we have the training for the all employee level, secure development life cycle, digital offer compliance to the security guideline, backup system and recovery maintenance path. Schneider Electric approach to security is solid. We are a founding member of the Global Cybersecurity Alliance. We are on with the GDPR and also compliance with the worldwide regulation. For instance, the SB 327 of the California IoT into the industrial customer perimeter. Our Secure Power CTO has the diligence to prepare policies, to prepare security in the book, and to cascade this protection into our offer. Our development is done using the principle of secure development life cycle from IEC 62443 and ISO 27001. As incident response, we have the corporate product cyber emergency response team that is following the ISO 30111. All the vulnerabilities are discovered with a solid path up to the resolution, and a new release with enhancement improvement is part of the product before to land to the market. So the cooling unit is equipped with a robust software. There is a robust requirement path behind, solid test, regression test, penetration test, service quality assurance steps before to introduce something into the market. If something is not running okay, there is a reverse path to identify the problem and to come back to the prior stage. And so the next release will incorporate the improvement. So our cool units are equipped with the top functionality, interaction with the HMI, building management system, Schneider, and third party. We offer different experience. Front of the unit, use the network management card, and also the COVID pandemic has increased the use of the Ethernet because there is a more necessity to have a remote troubleshooting, and also the use of cloud architecture. So we turn data into intelligence, we turn intelligence into analytics engineering, we turn analytics engineering into new secure, efficient, sustainable units front of the customer. So our EcoStruxure IT is the cloud architecture. We offer knowledge as a sum of the visibility inside. The data from data center is sent in secure, encrypted, protected way. We offer different experience, web dashboard, mobile app with a solid authentication, with two-factor authentication, finger authentication, as you prefer. Again, the possibility to select module and different experience according to the requirement and necessity. As key takeaways, for sure the cybersecurity threat is real and the hackers are also more smart. Defense in depth, cybersecurity training, secure development life cycle is our path to offer you reliable and cybersecure cooling machine. So we take seriously of our customer needs to become the right security partner. So looking at the future, we are ready to scrutinize the horizon with a secure eye. For more detail about data privacy, product application security, please have a look to our ecostructureit.com/security and to our website se.com cybersecurity section. Thanks for your attention and enjoy our Cool Innovation Day.
Hi, welcome to Cooling Innovation Day 2021. My name is Hidehiko Kinoshita, connecting from Schneider Electric Tokyo office. I'm very glad to be able to speak a word here. Our aim is to contribute to reducing our customers' carbon footprint with various technologies and offers. I would like to talk about one case in Japan. Until last year, uniflat chillers have never been sold in Japan because of the strong competitors, and it was not easy to comply with the high-pressure gas safety regulations. However, In order to build the latest highly efficient green data center, it is necessary to use a high-efficient free cooling chiller. Then, we take the help of strong recommendation from customers. We have prepared service systems, all required documents, and prepared the resources. And finally, we introduced the chiller in Japan for the first time in this.
Hi, my name is Miguel Lopez and welcome to the 2021 Cooling Innovation Day. I have great pleasure in presenting to you a specific topic on hyperscale critical cooling. It reminds me probably of 25 years ago when I first started in the industry, how critical cooling for hyperscale applications was predominantly the domain of cracks, CRAHs, and probably as of 15 years ago, in-row units. I'm happy to say that Schneider Electric has great capability in putting together engineered solutions, what we call ETOs, engineered to order, such as the product which I'll be talking to you about today. Over the period of time since the hyperscale boom has occurred, especially during the pandemic, we've seen quite a large interest in this particular product. The fan wall, or the FWCV, is a product that's been specifically developed for hyperscale co-location data centers. Here in our innovation hub here in our Sydney offices in Australia, we actually have the particular product down on the bottom left that you can see there. So it is one of the products that we do advertise and we do talk about to a great level. Today I'd like to do a bit of a deep dive. We have had some customers in the Pacific zone who have taken advantage of this product offering, have specified this particular hyperscale cooling solution and have deployed specifically in Australia. So without further ado, we'll just cover a few of the engineering kind of technical features of this product and why it's of benefit to clients. So today I'll be talking about the FWCV. So FWCV, otherwise known as a fan wall or a fan array. Imagine a data center or a computer room where the walls, the opposing walls of the facility are essentially an air chamber where the air is actually flooding the room or the rows of aisles immediately opposite each other. So this is the concept of a fan wall. It's essentially a wall which is converted into an air handling system for the air to be then gently transferred into the data room space. The hot air is then accumulated in the hot aisle and it's chimneyed back into the suction side of these fan wall units. So these fan wall units are around about 400 kilowatts in cooling capacity. They range from about 200 kilowatts. They're about 4 meters width, 1.5 meters in depth by about 4 meters in height. They come in two modules, a bottom module being 2 meters high and an upper module 2 meter high, making a total combined height of 4 meters. So some of the benefits that the client will take away are the superior kilowatts per square meter that you can achieve out of this relatively compact cooling unit. How does it work? As described, the fan walls are essentially delivering cold air into the computer room at velocities of around about 2.5 meters per second. So these are velocities that are quite attuned to the requirements of data center facilities. As the cold air makes its way into the data center, it's then absorbed by the IT equipment. The IT equipment through the racks is able to then cool the IT equipment, channel that hot air into a hot aisle. That hot aisle is then channeled or ducted back to the suction side of the fan wall. These fan walls, as I said, have a cooling capacity in the range of 500 kilowatts. The power consumption is relatively low in the range of 24 kilowatts. EER can be as high as 20. Airflows are in the range of 125,000 cubic meters per hour. Static pressures, given the fans that are in use, are around about 450 pascals. With an ESP of about 75 pascals. Water pressure drops of the internal water piping system is around 80 kPa. So these are essentially CRAH units or computer room air handlers. They're essentially a fan coil unit. You essentially have a big coil pretty much covering the entire face of the unit with an array of fans behind it, pushing the air across those coils, delivering that cold air into the room. The solution comes equipped with one water inlet and one water outlet at the upper superior level of the unit at 4 meters, making it very easy for the client to channel in, come in with his chilled water connection from the top, and the return pipes going back out through a similar location. The system is completely maintainable through the service corridor or the rear of the unit. Full maintenance access. Given the 1.6 meter depth of the unit, we have access chambers on the side of the unit to be able to do your preventative maintenance and inspections of the coils. The weight of these systems are around about 2.5 tons per module. So you have 2 modules, so you're looking at about 5 tons in total, or 5,000 kilograms in total of weight. So therefore, the application or the location of the site has to be very acutely aware of the point loads in the building to be able to sustain that weight. The units come with a proven controller which is deployed on our crack products. So these are the standard Uniflare controllers, tested and proven over decades of use, has been configured to be able to work for these fan wall units. So essentially what we're talking about is chilled water temperatures. Now we're talking about chilled water temperatures in the range of 20 degrees in, 30 degrees out. What this does, it gives us the ability to deliver air temperatures into the cold aisle in the range of 24 degrees. So 24 degrees is pretty much at an optimum level to which ASHRAE pretty much give guidance as to what the temperatures should be for the air entering the IT equipment. So 20 degree water with 30 degree leaving the air handler or the fan wall is actually quite optimal for then the chiller to take that 30 degree water and be able to cool that chilled water down to 20 degrees. By all means, it's not chilled water anymore because 20 degrees isn't chilled in the strictest sense of the word. However, it gives the opportunity for the external chiller, be it a Schneider chiller or others, to be able to be specified with a free cooling coil. Free cooling coil or an economizer at the chiller, thanks to the temperate temperatures, ambient temperatures here in the Pacific zone or elsewhere around the world, gives you the ability then to enable more economy hours or more free cooling hours at the chiller. So you can imagine 20 degree water being delivered, being produced by the chiller, is able then to be quite easily produced by ambient temperatures of around 16 degrees and below in almost 100% free cooling mode. So free cooling technologies, sustainable, innovative ideas for the cooling application for your data centers is pretty much at the core of Schneider Electric. Talk to you a little bit about installation. These units are quite large, quite heavy, 4 meters wide by 2 high by about 1.6 deep. The fact that they're 2.5 tons in weight means that they do need to be carried into location with cranes or with some kind of lifting system or forklift device to be able to position them. So therefore that means that your facility needs to be designed in such a way to facilitate forklifts or similar equipment to be able to mount and locate these units. Similarly, the top module will need the ability to have some kind of overhead craneage system to be able to position the upper units on the lower units. Once again, 2.5 tons per module, so it is quite sizable loads. The room itself would need to be adequately designed to be able to cater for these accessibility for your craneage and forklift equipment. Schneider Electric has CFD tools that can help with the analysis of what it would look and what it would take to design a floor area, a room of sorts, with service corridors at the ends of your room, lined with these fan wall units, and then to be able to design and have enough clearance for your lifting equipment for your installation. So these are some of the opportunities for value add that we offer to specifiers, room designers, and end users. Another feature of our installation is supply air dampers. So the fan wall being 4 meters wide by 4 meters tall, there might be an opportunity to deploy in a duty standby configuration. That would mean that the fan wall's in standby to prevent it being a point of bleeding of the air back through that fan wall, would have a series of dampers across the entire face of that unit. So the standby unit would be furnished with dampers, given the opportunity for the facility to be able to switch that unit off without any possibility of bypass air through that standby fan wall unit. So the damper system would be integral to the design of the fan wall. Part of the installation would also include a drain line from your drip tray. Whilst the temperatures are quite high on these applications, nevertheless, we do cater for the possibility of condensation at the coil. So if you do have condensation at the coil, there is a drip tray that comes fitted to the base of the fan wall unit that needs to be taken away through a drain line, just out to your drain services. So serviceability, I touched on serviceability earlier. Our fan wall design is designed to cater for very comprehensive and easily accessible service access through the side panels. So this makes it a lot more easier then to be able to gain access, inspect your air-on surfaces of your coils, inspect the discharge face of your fans, and do the corresponding preventative maintenances. These units will come with differential pressure switches to ensure that you have adequate pressure across the unit, to ensure that you do have a good proportion of air feeding the unit. In the event that any fans of this fan array should fail, these pressure differential switches will pick up that loss in differential pressure and raise the corresponding alarms. This product offer also comes with pressure independent control valves, giving the facility the option to have a pressure controlling system embedded inside the fan wall unit. So that's to control the chilled water pressure across your unit. So I hope this information has been useful to you. We look forward to you enjoying the rest of the Innovation Day, and thank you very much for your time.
Welcome to Cooling Innovation Day. My name is Sujit Kamble. I am responsible for cooling business development for Greater India. Today we are going to discuss on the customer success story for providing end-to-end cooling solutions where customer benefited achieving the best energy efficiency. This customer is the largest co-location and service provider in India, and here we not only supplied range of cooling products but an integrated cooling solution. So let's discuss more on this our success journey. So our journey started in 2015 with CRA, INRO and raised floor supply to this customer. Later on, gaining more customer confidence and trying to resolve their existing cooling issues, Schneider became a trusted partner, which resulted into end-to-end solution provider. Till date, this customer has about 50,000 square meter of access floor installed in their various projects in India, 750 plus CRA units and 50 plus air-cooled 400 TR chillers with and without free cooling and adiabatic cooling solutions. So this is about our success with this customer, and this journey is still continuing. So let's discuss more on the cooling solutions, what we offered, how we address the customer concern to achieve a better energy efficiency. As we know, 40 to 50% of energy consumption in data center attributes to the cooling. So this customer was looking for a best possible energy efficiency on cooling part. Customer has two major projects in Mumbai and Bangalore. Based on the cold aisle temperature design, Schneider optimized the chill water operating temperatures as 1522 for Mumbai region and 2027 for Bangalore project. Due to lower ambient temperature in Bangalore as compared to Mumbai, we offered free cooling chillers to this customer, which further improved energy efficiency by 15%. Chillers are offered with inbuilt inverter driven pumps with quick restart feature. These chillers didn't require any third-party integration like chiller plant manager, because that is an embedded function in a chiller controller. So what made them to buy this chiller? It is like a plug and play chillers, what we call, because everything is inside the chiller and you just connect chill water pipes without need of any third-party integration, and they are ready to deliver the required chill water temperatures and ready to transfer the data directly to the BMS without any need of third-party integration. So this solution has given customer total cost of ownership less than 3 years. So that is what the customer were looking, and Schneider helped them to gain this their target efficiency and PUE, which was committed to their end users. So customer also had a concern about the optimizing the thermal energy storage tank sizing, because that is the item which takes a lot of space on the terrace where we install chiller along with thermal storage tank. So with quick restart feature, where what we offered for this customer, so during chiller restart cycle, chiller comes to full load condition within 120 seconds. So how does it help? So generally a traditional approach where chiller takes 8 to 10 minutes to come to full load condition after restart, your thermal storage tank size has to be designed basis this quick restart time. So with 120 seconds, the thermal storage tank was reduced by 1/3. So that was a drastic reduction and benefit to the customer. So also customer the HVAC scheme of this customer was designed such that the storage tanks were placed in a bypass loop, and chillers are supplying chill water directly to DC, bypassing these tanks. So this, whenever the quick restart cycle is into picture, or whenever there is a change of power supply, thermal tanks used to support the data center with required chill water. So what happens when the chiller gets powered on again, that is during restart? So to avoid return water from data center directly pushed to supply side, a customized bypass loop was designed on each chiller using 2 motorized valves. Hence, during any such situation, data center is always fed with a designed supply water temperature. So data center is not getting affected with all these restarts on the chillers or on the overall data center operation. So this was the very unique benefit to the customer. So another concern was customer the existing installed chiller at their existing facilities has a major issue on maintaining the design chill water temperature during high ambient conditions, because those chillers having a lot of recirculated air which is going to the chiller inlet, and that is where chiller were getting derated. The installed chiller requires elevated platform because of its coil design, so there was no enough space was available. So we addressed this concern by offering a chiller which can operate up to 52 degrees centigrade ambient temperature without tripping, and also even if the temperature goes beyond, the chiller has inbuilt adiabatic kit which maintains the required inlet air temperature to the chiller to optimize its energy efficiency. So chiller also has a W-shaped condenser coil which does not require any bottom clearance. Chiller has anti-recirculation devices on the fans which avoids any hot air recirculation, and this is where the customer got he got a confidence in our solution. So the chillers, because of all these features, chiller we can keep the chiller distance between two chillers within 2.5 meters. So that was a very good benefit to the customer. That is how the customer could place more chillers in the available space in their data centers. So we also have the adiabatic system on chillers inbuilt inside the frame without taking any additional space. So it was giving further energy efficiency. This solution of adiabatic system, which we call advanced mist-based system, has it takes benefit during high ambient temperature condition during summer months, and due to lower wet bulb approach, it pre-cools the air temperature which is entering into the condenser coil. So this advanced mist-based adiabatic system consumes very less water. It is less than 2.5 liter per hour per TR, which is almost 1/4 of a cooling tower. So you can imagine with less water consumption, it gives further improved efficiency and offer TCO, that is total cost of ownership, less than 2 years. So that was the added benefit and added operating efficiency which customer could gain. For the Bangalore data center, for this customer, due to its higher operating chill water temperatures and also due to low ambient temperature condition in Bangalore, we offered free cooling coils. So free cooling coils also, without changing their basic dimension or basic frame of the chiller, the free cooling coil got incorporated along with the condenser coils, which resulted into a 15% energy saving and annual energy saving for the customers. And you can see here is a snapshot of actual power consumption during one of the free cooling cycles, where chiller started giving free cooling benefits whenever the ambient is lower than the return water temperatures. So this is we discussed about the chill water, the chillers, which has given the optimum solution to the customer with having a highest energy efficiency. Now let's discuss about the CRA offer which we offer to the customer. So we call it as PAHU or CRA. So these CRAs are offered with, again, later generation EC fan, which consumes very low power consumption of less than 0.12 kilowatt per TR. Also, this airflow control was based on the automatic floor pressurization system. We call it APS system. So this is also very unique energy efficiency feature which we offer to the customer, which maintains a positive pressure in all the cold aisles inside the data center with minimal or optimal airflow supplied to each and every rack. So this CRA also, along with this condition, we offered customer our FAT, factory acceptance test in our in-house cyclotic test lab, where customer visited and witnessed the actual energy saving benefits, and that is how we gain more confidence from the customer. So let's discuss more about this automatic floor pressurization system. So this system basically, which ensures each and every cold aisle inside a data hall is positively pressurized without consuming any extra fan power. So this gives a lot of advantage compared to traditional method of airflow control using temperature sensors. So there are multiple pressure sensors which are installed in cold aisle and hot aisle. So the positive pressure sensor, which is in the cold aisle, which always maintains the positive pressure inside cold aisle, and which ensures all racks are getting optimum and its required airflow without affecting the overall energy efficiency. So we also offered this customer access floor system. So access floor system was again one of the key criteria for the customer, where the customer has a concern of higher air leakage rates leading to lower cooling efficiency. They also had an issue with low fire resistance from the existing floor. And also one of the concern was the chill water pipes which are running in the corridor area, which needs a special understructure system, because generally the understructure system is in the form of 600 by 600 degree structure. So what if there are large pipes running inside the hall, and how we can mitigate? So we address this concern by offering our high density calcium sulfate panels, which offered a very lowest air leakage rate because of its dimensional tolerances, which are very low. And also it has a gasketing system, the stringer system, which is installed over the pedestal, which also reduces the air leakages inside the data hall. So with this system we could conduct a test after commissioning of the data hall, and which resulted into less than 5% air leakages. So apart from air leakages, the customer also got benefited with improved cooling efficiency because of these lower losses, and cooling efficiency was increased by 9%. So this is how we mitigated the issue of higher leakage rate. Then this calcium sulfate floor has certified for 60 minutes fire resistance as per the European EN 13501 norm. So this also resolved customer concern of fire resistance or fire rating. And for the third concern on the corridor area where chill water pipes are running, we offered a specialized structure of 600 by 1200 understructure system, where chill water pipes can easily run without affecting the understructure system. And also this system was tested in our Consalve, Italy factory, where we produced the results of this system for the design, point load, and the air leakages. We have end-to-end solution. We offered cold aisle containment racks to this customer. So this cold aisle containment was specially designed to have no air leakages from the cold aisle, where cold air tries to escape and mix into the hot air. So that was one of the benefit. Other benefit was also because of this cold aisle system, we were able to maintain a good positive pressure system, which was required for the CRA EC fans to operate at its optimum level. And this is how we provided an end-to-end solution to the customer, where our factory implementation and execution and support capability, which made customer satisfied. So it was not only the solution positioning of the cooling solution, but it also made customer aware that what kind of support system we have, and how we delivered that, and we are continue to deliver that, and we gain we have win-win situation with this customer. So thanks a lot.